Hello everyone, you're welcome to solve this nice algebra problem, which is a plus b. This is equal to 10. Let's call this equation 1. A times b, this is equal to 10. Let's call this equation 2. So what is the value of a and what is the value of b? Now let's prevent the solution from here. Now from equation 1, which is a plus b, this is equal to 10. Let's make a to be the subject of the formula in this case, so that now a will be equal to 10 minus b. Let's call this equation 3. Now let's substitute equation 3 into equation 2. Equation 2 is ab is equal to 10. So let's substitute the value of a with 10 minus b. So we have b times 10 minus b. This is equal to 10. So here we have b times 10. This is 10b minus b times b. This is b squared. This is equal to 10. Let's take 10 on the left hand side, so that now we have 10b minus b squared minus 10. This is equal to 0. Let's rearrange this equation so that we have minus b squared plus 10b minus 10. This is equal to 0. So this implies that from here, let's divide both sides by minus 1. So minus b squared divided by minus 1. This becomes b squared. Then plus 10b divided by minus 1. This becomes minus 10b. Then minus 10 divided by minus 1. This becomes plus 10. This is equal to 0. Now, this is a quadratic equation whereby a is equal to 1, b is equal to minus 10, and c is equal to 10. To solve for b1, b2, we apply the quadratic formula, that's minus b plus or minus the square root of b squared minus 4ac, everything here divided by 2 times a. So let's substitute the values of a, b, and c from here, so that we have minus 10 plus or minus the square root of b squared, this is minus 10 squared, minus 4 times a, which is 1, then times c, which is 10. Everything here divided by 2 times 1. The next step is that minus times minus 10, this is 10, plus or minus the square root of minus 10 squared, this is 100, then subtract 4 times 10, this is 40, then everything here divided by 2. So this implies that here we have 10 plus or minus the square root of 100 minus 40. This is the square root of 60. Everything here divided by 2. Now, the next step from here, we can express the square root of 60. This can be expressed as, now this is equal to 10 plus or minus the square root of 60 can be expressed as 12 times 5. Everything here divided by 2. And this is equal to 10 plus or minus the square root of, we can express 12 as 4 times 3 times 5. Everything here divided by 2. So this implies that here we have 10 plus or minus the square root of 4, this is 2. Then we have square root of 3 times 5, which is 15. Everything here divided by 2. So the next step from here, we can factor out 2 so that we have 2 into the parentheses. This is 5 plus or minus square root of 15 divided by 2. So let's simplify here so that now b1, b2, this is equal to 5 plus or minus square root of 15. So this implies that b1 is equal to 5 plus square root of 15. we have b2 is equal to 5 minus square root of 15. So the next step is to solve for the corresponding values of a. So if you recall from equation 3, we have that a is equal to 10 minus b. So this implies that a1 is equal to 10 minus b1, which is equal to 5, plus square root of 15. So therefore from here, we have a1 is equal to 10 minus 5, which is 5, minus times plus square root of 15. This is minus square root of 15. So this implies that a1 comma b1, this is the same thing as 5 minus square root of 15, comma b1, which is 5 plus square root of 15. So this is the first set of solution that we have. This is the first set of solution that we have. So let's solve for a2 from here. a2 is equal to 10 minus b2. So this implies that a2 is equal to 10 minus b2, which is 5, minus square root of 15. So this is equal to 10 minus 5. This is 5. Minus times minus square root of 15. This is plus square root of 15. So we have the second set of solution, a2 comma b2. This is equal to 5 plus square root of 15, comma 5 minus square root of 15. So this is the second set of solution that we have for this algebra problem. So the next step from here, let's verify that these two set of solution here satisfies the equation. Let's verify that a1, b1 and a2, b2 satisfies the equation. Now, if you recall from here, we have that a plus b, this is equal to 10, and that's a times b, this is equal to 10. So this is equation 1, and this is equation 2. So let's verify a1, b1 by applying equation 1 from here. So from equation 1, we have 5 minus square root of 15 plus 5 plus square root of 15. This should give us a value of 10. So we find that minus square root of 15 and plus square root of 15 simplifies, so that we have 5 plus 5, this is equal to 10, and this is equal to 10. This implies that the left hand side is equal to the right hand side, and this implies that a1, b1 satisfies the equation. Now, let's check a2, b2 by applying equation 2, which is ab, this is equal to 10. So we have 5 plus square root of 15 multiplied by 5 minus square root of 15. This should give us a value of 10. So we have 5 times 5 minus square root of 15 plus square root of 15 multiplied by 5 minus square root of 15. This should give us a value of 10. So 5 times 5 here, this is 25, minus 5 times square root of 15, this is 5 square root of 15, then plus square root of 15 times 5, so this is 5 square root of 15, and then here we have plus square root of 15 times, here we have square root of 15 times square root of 15. So this becomes minus. So this is minus square root of 15 times square root of 15. This should give us a value of 10. So here we have minus 5 square root of 15 simplifies. So that now we have 25 minus, now square root of 15, we have square root of 15 times square root of 15. This is equal to 15. Let's substitute this. So we have 25 minus 15. This should give us a value of 10. 25 minus 15, this is equal to 10, which is equal to 10. So the left add side is equal to the right add side. And this proves that A2B2 satisfies the equation. So kindly follow the steps. Don't forget the steps. Like this video and subscribe. Kindly like this video and subscribe. See you in the next video.